In this example, we're asked to find the probability of drawing either an ace or a heart from a deck of 52 playing cards. Here we see the values of the playing cards and the suits. So for the suits, we have clubs, spades, hearts, and diamonds. And then for each suit, we have 13 cards, ace through king. The events are defined for you. Here, A is the event that an ace is drawn, and H is the event that a heart is drawn. In this picture, the deck is shown in order, but we would shuffle the deck so that we can select a card at random. And so we'll start by writing the probability statement. We use a P for the probability. And so what is the probability of drawing either an ace or a heart? So A or H. We can also write this as the probability of A union H. Next, we'll find the probability that an ace is selected, probability of A. So let's look at the picture. I'm going to outline all of the aces. There are 4. And so there are 4 aces out of 52 cards. Therefore, the probability of selecting an ace is 4 out of 52. Next, let's find the probability that a heart is selected. We'll define that as P of H. And then let's outline all of the hearts. There are 13 hearts out of the 52 cards. So 13 out of 52. Let's return back to some of our rules. We saw the addition rule for 2 mutually exclusive events. Mutually exclusive events are events that can't happen at the same time. They do not share any simple events from the sample space. Here you see the Venn diagram. We have the sample space in the rectangle. Event A would contain all the simple events from the sample space that fit the definition of A, and then event B contains the simple events from the sample space that fit the definition of B. And you see that they do not have any simple events in common. There's no overlap. So for 2 mutually exclusive events, we saw that we could use this to calculate the probability of A union B, which is just the probability of A plus the probability of B. We can also use this general addition rule for any 2 events, whether or not they're mutually exclusive. The probability of A union B, or A or B, is equal to the probability of A plus the probability of B minus the probability of A and B. If the 2 events are not mutually exclusive, they do share some simple events from the sample space, and there's overlap. If you just add up the probability of A and B, and you don't subtract the probability of A and B, then you're counting that overlap twice. Here we have the event A, and here the event B. And here we have some overlap, so they share at least one simple event from the sample space. They're not mutually exclusive. And you can also see from this that this formula works for mutually exclusive events also, because the probability of A and B is equal to 0. So returning to the example, we'll find the probability of A or H, and we'll use the general addition rule for any 2 events, because that works in all situations. We'll take the probability of A, which is equal to the 4 over 52, plus the probability of H, which is 13 over 52. And then we'll subtract the probability of A and H. So you can either write that as A intersection H, or you could put an and instead of the intersection sign. Either is fine. So let's see if they share any simple events in common. And they do. Because the ace of hearts is both an ace and a heart. So what is the probability of selecting the ace of hearts? Well, it's 1 card out of 52. So we're going to subtract 1 out of 52. Therefore, we get a final probability answer of 16 over 52. You can see if we just would have added up the probability of A plus H, the blue and the green, we would have double counted that ace of hearts, because we can see really clearly from this sketch that there is overlap in the sample space.